Right, section 6 is going to be about adding and subtracting rational expressions. Now, we've already seen multiplying and dividing our rational expressions, which you can do with any rational expressions. It's always best to factor them first, but you can do it with any of them. When adding and subtracting rational expressions, though, they must have a common denominator. I want you to circle this one or underline it or do something to show this is very important. They have to have a common denominator first. So to help you find that common denominator, you'll factor and create a common denominator. And I'll show you how to do that in our coming up examples. After you have the common denominator, then you'll add or subtract the numerators, and the denominators will stay the same because they're that common denominator. Be sure to distribute the negative under subtraction. So if they're if your problem is this rational expression minus this one, you have to distribute that minus to each term. And again, I'll show you what that looks like in one of our examples, or a few of them. At the end, after you've added or subtracted everything together, you have to simplify. Whether that's distributing, foiling, refactoring, canceling, all of the above, you have to simplify at the end then. So let's see what this looks like in some of our examples. Now, as a review, to kind of help us remember what this looks like, we're going to use rational expressions just with whole numbers. These are just basic fractions. So 1 over 2 plus 2 over 3. How do we add these two fractions? Well, we need a common denominator. Step 1 must have a common denominator. Right now we've got 2 and 3. So this is how we build our common denominator. We look at all of the factors of each. All the factors of 2 is just 2. Factors of 3 is just 3. So 2 times 3 will help us find our common denominator. That's 6. How do we get this denominator to be a 6? Well, we need to have all of these factors in there. We already have the 2, so we need the 3. We're going to multiply by 3. If we multiply the bottom by 3, we have to multiply the top by 3. And why this works is because 3 over 3 is just 1. So really, we're just multiplying this fraction by 1. Same thing over here. We've got 3 alone. We need to have 3 times 2. So we add this times 2 on top and on bottom. We're multiplying by 1 basically. 2 over 2 is just 1. So we're multiplying this fraction, 2 over 3, by 1. In the end, this will help us find our common denominator. So over here, 3 times 1 and 3 times 2 becomes 3 over 6. Okay, 1/2 is the same as 3 over 6. Makes sense. Same thing, 2 over 3 times 2 over 2 becomes 4 over 6. 2/3 is the same as 4/6. Again, should make sense, but really what happened was we're factoring out to find this common denominator. 6 is 2 times 3. Both of these denominators are found inside of this denominator. Now that we have a common denominator, we just add the numerators across. So 3 plus 4 is 7. So we call it 7/6. Or, if you'd like, we can call it 1 and 1/6. This would be the mixed number version. This would be an improper fraction. For whole number fractions like this, either one is acceptable. But that is, again, that's kind of the process we're going to be looking for. Get the denominators the same, add or subtract the numerators, and then simplify at the end. Let's do the same thing but with subtraction. Here we've got 6 and 9. Well, 6 is the same as 2 times 3. Okay, that's its factors. We broke it down. 9 is the same as 3 times 3. Or we can call it 3 squared. It might be easier to leave it as just one base to a power. So when we're looking at our denominator, our common denominator, we have to have each of these bases, 2 and 3, and then 3 happens again over here. 3 happens here and here. We have to have a 2, we have to have a 3, and we need the biggest power of 3. This is a 3 to the 1, this is a 3 to the 2, so we need it to be 3 to the 2. This is our common denominator, 2 times 3 squared. Now, to help us with that, we can say, what would that exactly come out to be? Well, it's actually 18. 3 squared is 9, times 2 is 18. So our common denominator should come out to 18. Using our factored common denominator, though, 6 we recognize as 2 times 3. So what are we missing from this common denominator? We're missing a second 3. So that's what we need to multiply the top and the bottom by. Oops, 3. 3 over 3 is what we're multiplying this one by. Same thing. 9 we recognize as 3 squared. What are we missing from this piece, the 2 times 3 squared? We're missing a times 2. So we do that on top and on bottom. When we do this, both of these will get the same common denominator, 2 times 3 squared, or 18, and we'll have different numerators then that we can actually add or subtract. So 3 times 1 and 3 times 6 becomes 3 over 18. 2 times 2 and 9 times 2 become 4 over 18. Now we have a common denominator, so we just subtract as we normally would. 3 minus 4 becomes negative 1. So we leave our common denominator and we call it negative 1 over 18. Now with negatives, remember you can always call this negative 1 over 18. You can move the negative out front and call it negative 1/18. Or if you really wanted, you could do 1 over negative 18. As long as this negative is somewhere present, it really doesn't matter. Now, I think it's probably easiest, oops, I need to scratch that one out. It might be easiest always to take the negative out front. So we'll call it negative 1/18. This would be your final answer then. So again, this is the process we're doing. Let's look at some examples of adding rational expressions. Now here we've got 3x over 8y squared x plus x minus h over 8y squared x. Notice, we already have a common denominator. So we really don't have to do anything to make a common denominator. We just start by adding everything together. 3x plus this whole thing, this x minus y. When we distribute this positive or this plus, it means we can basically get rid of these parentheses. So 3x plus x minus y. When we do that, 3x plus x becomes 4x, and we still have a minus y. So this is going to be our kind of simplified numerator over our denominator. Now we need to check to see if we can simplify any more. This top piece will not factor. There's nothing we can take out of each of these, and we have to think of this whole factor as being 4x minus y. Is there another 4x minus y down here? No, there's not, so we can't cancel anything out at all. So we just say this is our final answer. 4x minus y all over 8y squared x. This would be our answer for this addition problem. Let's do another one. R plus 3 over r squared plus r minus 2 plus r minus 6 over r squared plus r minus 2. Now again, we can notice common denominator is already there. So that'll make things easy. We don't have to change our numerator at all, but we are going to have to factor it just to help us in the future here. R squared plus r minus 2, if we do the AC method of factoring, it becomes r minus 1 times r plus 2. Okay, so this is our factored denominator, still with our numerator of r plus 3 on top, plus r minus 6 on top, r minus 1, r plus 2. Notice, common denominator is already present. So what we're doing is just adding everything. Still r minus 1, r plus 2. When we add everything, it just becomes r plus 3 plus r minus 6. This factor plus this factor. Now, again, like before, when we're just adding things, we really don't need these parentheses. Oops, I'm going to get rid of those. So it should look something like this. R plus 3 plus r minus 6. I'm going to spread these out a little bit too. Oops, I want right there. So, when we put our common denominators, or our common like terms together, we have r plus r would make 2r, and positive 3 minus 6 would make minus 3. So we've got 2r minus 3. That was this numerator simplified. Now this numerator will still be over our common denominator of r minus 1, r plus 2. This numerator we cannot simplify, we cannot factor anything out and start to cancel. So we need to check, can this whole factor, this whole piece, cancel with anything down here? No, it cannot. So at this point we would say this would be our final answer in a factored form. If you wanted to leave things in factored form, this is okay. It's okay to leave your answers like this. You can also, especially if the question asks you to, expand everything. When I say expand, I mean actually FOIL everything out. So this would be your expanded final version. The 2r minus 3 stays on top. That's still our numerator. But r minus 1 times r plus 2, that just goes back to the beginning. What was our common denominator from the beginning? R squared plus r minus 2. Some textbooks or some teachers will prefer this one. I'm not too picky. If you left it in either one of these, that would be okay. This one might help because of canceling things out. This one might make a little more sense because it's actually all expanded out. There's no parentheses there. Either one is fine. Let's look at another example here. We have a common numerator of 5, but that doesn't help us. We're not looking for the numerator, we're looking for our denominators. Our first denominator is 2 times x times y. Our second denominator is 3 times x times y. So when we try to find our common denominator, it should have one of each of these, a 2, an x, and a y. 2x and y. It should also have a 3. There's a 3. We already have an x, we already have a y, we don't have to worry about those. We do just need to check and make sure that they all have the highest power. Each of these x's is to the first power, so we don't have to worry about it. Each of these y's is to the first power, so we don't have to worry about it. So right here then is our common denominator as a factored form. Expand it out. This is going to be our, or should I say simplified out, this is going to be our common denominator. It will become 6xy. So using our factored form, we're going to see how we need to change each of our two rational expressions. 2 times x times y times 3. What are we missing in this one? Well, we're missing that times 3. So we need to multiply top and bottom by 3. 2 times x times y times 3. What are we missing in this one? We have the 3, the x, and the y, so we're missing times 2. So simplifying each piece. 3 times 5 and 3 times 2xy. Oops, that. We get 15 all over 6xy. That was our first piece. 5 times 2 over 3 times x times y times 2 becomes 10 over 6xy. Again, notice we have that common denominator, so we're ready just to add. 15 plus 10 becomes 25 all over 6xy. Now, we always need to check, can we cancel anything out? If we were to try to factor this, the only things we could take out would be 5. And 5 won't cancel with 6 at all. So we know we can't cancel anything out of top and bottom, so this would be our final answer. 25 over 6xy. Alright, we've got one more example using addition. 4 over x minus 2 plus 6x over x minus 5. We have x minus 2, we have x minus 5. Those are going to be our two factors. So we're looking at our common denominator. Because this is a subtraction or addition, either way, this whole thing needs to be considered the factor. It's this whole piece that is the denominator. You can't separate them as two things because it's not negative 5 times x, it's x minus 5. So here we have our two factors. When we try to make our common denominator, it'll look like x minus 2 times x minus 5. We had to take each factor into consideration. When we spell it all out then, our common denominator is going to be x squared minus 7x plus 10. And again, that was just because we FOILed this out. X times x is x squared, x times negative 5 is negative 5x, negative 2 times x is negative 2x, negative 2 times negative 5 is positive 10, and the negative 5x and the negative 2x combine to a negative 7x, or minus 7x. So, either one you look at, this or this is our common denominator. Use the factored form of the common denominator to find out what your new numerators are going to be. This rational expression over here already has the x minus 2, so we need x minus 5 to be multiplied on top and on bottom. X minus 5. Oh, that doesn't, there we go, that looks like an x minus 5 now. When we look at our second one, this has an x minus 5, so what are we trying to multiply into here? the x minus 2. We need to multiply top and bottom by this x minus 2. This whole expression now, 4 times x minus 5 becomes 4x minus 20 over, we'll leave it in the factored form, x minus 2, x minus 5. This one over here, 6x times x minus 2, it's going to become 6x squared minus 12x. So this is what our new problem looks like. Just the two rational expressions added together. They do have a common denominator, this x minus 2 times x minus 5. This one I just wrote them right next to each other. Here I wrote in the multiply. You can actually see it's x minus 2 times x minus 5. You really don't need it. You can get rid of it just as easy. Now we need to just add everything together. Our highest x squared in here, we don't have x squareds at all over here, just this 6x squared. So that'll be the first thing on top. We need to recognize 4x plus negative 12x. What's 4 plus negative 12? That'll become negative 8x. And then just the constants alone, we have negative 20. There is no other constant for this to combine with, so we just have 6x squared minus 8x minus 20. At this point then, let's see if we can factor this top piece to try to cancel things out. We can take 2 out of all of those things, and it leaves 3x squared minus 4x minus 10. And if we try to AC this 3x squared minus 4x minus 10, we cannot do an AC factoring method here, because 3 times negative 10 is negative 30. There are no factors of negative 30 that would add to negative 4. So this is our fully factored numerator still over that denominator. Our common denominator stays. So if you would like, you can leave your answer in factored form like this, or you can spell it all out as 6x squared minus 8x minus 20 all over x squared minus 7x plus 10. Either one of these works. One is just all factored. One is all spelled out and expanded. Either one works just fine. And let's hold off for subtraction till our next video.